Okay, welcome back. We're at week 6. So for this week, I'm going to do something, again, focusing more on stuff that we've already talked about and things that you guys have already studied. So I'm going to have you guys do a little project that we call the physics of. I call it the physics of and leave it there because this is a chance for you to pick something that you're interested in. So if you have an interest in some sort of activity that you do, this could be, if you're a golfer, if you play baseball, if you shoot, just any activity at all that you're interested in. This is a chance to look at some of the physics behind that. Now, with that, I want you to be very, very specific in what you're doing. I don't want you to look at all aspects of that because it's way, way too overwhelming. Just one or two things. And I want you to make them things that you're actually interested in to help benefit you in that activity. So, if you're a baseball player, maybe it's all right. How do I hit the ball with more power? If you're a soccer player, maybe it's all right. How do I put more English on the ball, and how do I curve it more? It could be anything along those lines. If you're a golfer, how do I hit the ball further or with more spin? Just pay attention to just one or two specific aspects of that activity and something that you actually want to know about. So, looking at the rubric real quick, you should have a written description of what you're looking at. So again, and when you're doing these projects, you can do them in a number of ways. If you want to do a video, that's fine. In the past, I've just had people do them on Google Slides. That's fine also. But use the rubric basically as a checklist. Do I have this? Is it explained to the best of my ability? And if it is, check it off and you're probably going to be okay. So again, written description of your focus, a list of resources and bibliography. Make sure that if you're quoting something or if you're pulling a graphic, you give credit to where credit is due. Don't be just taking other people's work as your own. And then, of course, just having it done is the third thing. So those are your checkpoints, just to kind of give you an idea. As far as the actual requirements, first thing is a KWL chart. KWL is what you know, what you want to know, and what you've learned. So when you're talking about the K, just talk about some of the physics that you know about, again, the specific activity or specific event. What do you know about it? What physics do you know? Okay, the W is what do you want to know? So in the specific activity that you're doing and the aspects that you're focusing on, what do you want to know? Do you want to, again, going back to those examples that I had earlier, if you're a baseball player, how do you generate more power? If you're a golfer, how do you get more spin? I want this to be something that's actually beneficial to you. Okay, and then the learn part, obviously, what did you learn about it? So I learned that if I make contact with the ball for a longer period of time, I'll increase the impulse on the ball, and as a result, a greater transfer of energy, all that fun stuff. Okay, so that's the KWL chart. Force diagrams. Again, we're focusing on just specific activities. So in those specific one or two parts, I want you to have force diagrams explaining what's going on at that moment as these objects are interacting. You need to have at least two. Okay? Discussed in own terms, language suitable for a first-year physics student. I don't want you to just go find something online and copy it and paste it in. Write it in a way that would make sense to you and your friends. And if you need help with that, that's why we have our email correspondence and our Zoom meeting times. Diagrams. So this would be actual, like drawing sketches or pictures of that activity going on. And again, specifically the aspect or the interactions that you're focusing on. LOL chart, again, dealing with transfer of energy. So before whatever this specific event of your activity happened and during and after, how does the energy change? So basically, I just want to, again, keeping track of the conservation of energy. Where did the energy start? Where did it go? What types or what forms was it in? Demonstration of event. A video for this is fine. That could be something that you find online or something that that you make yourself. I'm not really worried about that, but you can go ahead and embed that in your slideshow or whatever. And then lastly, mathematical explanation, as much as you can understand. So again, when we're talking about force diagrams, then you should be able to write, this amount of force equals this amount of force. So you can talk about Newton's third laws. And other things, you could talk about the amount of kinetic energy using our kinetic energy formula, or elastic energy using that formula. Just stick with the things that we already know. If you want to go something a little more advanced, that's fine. You can include that. But I really want you to be able to explain what's happening in that equation and how the different variables interact with each other. Okay, so those are your requirements for this project. And then lastly, creativity and neatness. Is it creative? I don't mean super busy with a ton of pictures and stuff. I mean, that's all right, but just creative as in you went and found some not first thing up on Google search, click and copy and paste. Neat. Again, I shouldn't have to go and looking for everything. And flows. So as it goes from one thing to the next, just looking for a decent flow. Those are just basic points that you should have for any project or any basically anything that you're doing for school. Okay, so again, the physics of project. Again, it doesn't have to be just the things that I listed. Those are just some examples of some things that are done in the past. If you're not sure, if you're having trouble finding sources, again, please email me or come to the Zoom meeting, or most of you have my number. You can text or whatever needs to be done. So with that, I hope you all have a great week. And not only that, it looks like this weekend's shaping up to be really nice. So if you can get out and practice some social distancing, get out and enjoy this beautiful Michigan weather. And I will talk to you all later. Goodbye.